So now with this R square, or the this correlation of determination that we have, the main difference is just you take your R value and then you square it. But the reason why it's very important, because it's a very good or important indicator of the usefulness of the regression equation. How is it really useful to perform the R? Because this one will measure directly how strongly X and Y are associated. Because the first one with R, we only get how strong is that linear association. But now with this one, it will tell us how strong those two are associated. And the closer this R square is to 1 or to 100%, then the stronger the association between the two is also. And the opposite applies. If it's closer to 0, then it's a very weak association. And from this figure, you already guess that 0 means none, moderate. Now you see, with the previous one, when we had 0, told us there was no correlation. But this one now, when you're at 0.5 here, you have what? A 50%. And there we started from -1 to +1. Here we're only starting from 0 to 1, where half here means moderate. So you must really pay attention and do not confuse the two. The other one was from -1 to +1, with 0 being no correlation. But this one we're starting from 0 to 1 and 0.5 being a moderate association, like I've explained. And we can try now and apply this to the scenario that we had previously. I'm just gonna write, given that if you know that your R here was equal to what? To 0.8198. Therefore, your R square, if you square that value, should give you now 0.6721, or in percentage you get 67.21%. And this will tell us now that there is 67% of the variation in flat TV cells, right? In the what will mean there that the newspaper advertisement have a moderate, you see 67. So somewhere here, let me just change color. So 67 probably somewhere here, then it means that that newspaper is somehow a moderate to strong association. So it's telling us that we have a moderate to a strong association, or moderate to strong impact on the cell. So you're trying to see what is the actual impact. Is it a very strong? Because although you have that correlation, but is it very strong? Is it weak? And this can definitely help you making decisions moving onward. So that is why we calculate this type of correlation determination.